welcome to Science with Kanush. Today we'll be doing IGCSE Physics, the 1.3 mass and weight. So this is the syllabus content. So let's get started. First of all, what is mass? By definition, mass is the measure of how much matter is in an object when it is at rest relative to the observer. Now the phrase when it is at rest relative to the observer, so when we measure mass, the object should be at rest, and because if you notice, a moving car would be tough to measure the mass for. When the car is at rest, we can easily measure the mass, so it should be at rest. And the units of mass are kilograms. Now mass is a scalar quantity. That means it only has a magnitude, there is no direction, and it does not change regardless of the location. So it will be the same on Earth, Moon, Mars, Jupiter. Everywhere the mass of an object will be the same. Now, what is weight? Weight is the gravitational force acting on an object with mass. So weight is measured in newtons, and the formula for weight is W is equal to mg, where g is the gravitational field strength. So G is measured in Newton per kilogram, weight is in newtons, and mass is in kilograms. So unlike mass, weight depends on the gravitational field strength, and the gravitational field strength on every planet, and it depends, it changes on every planet, and hence the weight also changes, but the mass stays the same. Uh, then we have the gravitational field strength. So, gravitational field strength is the amount of gravitational force acting on an object per unit mass. As I said, in the formula W is equal to mg, the g is the gravitational field strength. So, when we rearrange for gravitational field strength, we will have g is equal to W by m. Like the mass will go on the other side, and since it's in multiplication over here, on the other side it will be in division, so it will become g is equal to W by m. We can also make a formula triangle to remember this. So formula triangle works like this: W m g. So basically, if we want to find weight, we will cover the W with our finger, and we'll see, and here there's supposed to be multiplication sign, sorry. Yeah, so when we have to calculate W, we can cover W with our finger, so we'll have mass times gravitational field strength basically. And this gravitational field strength is also the uh, acceleration of free fall. So let's say when we have to find G, we'll cover G, so we'll get W by m, and when we have to get m, we'll have W by g. So this is how a formula triangle works. It just makes it easier to learn a formula, and it doesn't take much time to rearrange. Then we have the unit. I already told, that's Newton per kilogram. The Earth's gravitational field strength is approximately 9.8 Newton per kg. So that's also equal to the acceleration of free fall on Earth. Then we have the relationship between mass and weight. So weight is the effect of the gravitational field on an object's mass. So the effect which gravitational field has on a mass is called weight. And since the gravitational field strength changes, as I told, the weight changes, but the mass remains constant. So for example, an object with a mass of 1 kg has a weight of 9.8 Newton on Earth, and on the moon it will have same mass 1 kg, but the weight of the object on moon would become 1.6 Newton, because the gravitational field strength on moon is 1.6 Newton per kg. You don't have to know the gravitational field strength on moon, but I was just giving an example. So we have the practical application. It's basically the weight and the mass of two objects can be compared using a balance, because the gravitational field strength is constant on Earth. So then we have density, that is 1.4, and this is the syllabus content. So we'll move on to density. What is density? Density is basically mass per unit volume of a substance. Density, we have the formula rho is equal to m by v. Now, the symbol rho, we use it to represent density. Rho means density. This symbol is called rho. Okay, and rho is equal to mass by volume. Density is measured in kilogram per meter cube. We can also derive this unit because mass is in kg, as I told, and volume is in meter cube. So the SI unit of density is kilogram per meter cube. Now, to determine the density, also density indicates how compact the matter in a substance is. So, substances with higher densities have more mass in the same volume compared to substances with lower density. So, we have, let's say, two glasses, okay, and the volume of the glass is same because they are of the same size, the same shape, everything is same. In one glass you add water, and in another glass if you add juice, the glass with the juice will be more heavier, a bit more heavier compared to the glass with water. That means that the juice is having a greater density because in the same volume there is a higher amount of mass. So that's what density tells us. Then determining the density of different materials. So first we'll learn how to determine the density of a liquid. We have to take a balance and measure the mass of an empty container, let's say a beaker, and then we fill the beaker with a known volume of the liquid. We measure the mass of the container with the liquid, and then we subtract the mass of the empty container, the empty beaker, and the mass of the beaker plus the water. So when we subtract that, we'll get the mass of the liquid. And then measuring the volume. To measure the volume, we can use a measuring cylinder or a graduated container to measure the volume. And then we have to calculate the density using the formula which I have told. Rho is equal to m by v. Then we have the density of regularly shaped solids. So for that, we again measure the mass using a balance. And then for the volume, we have to calculate the volume based on the shape's geometrical formula. So for example, for a cube, we know that V is equal to side cube. And for the cylinder, we know V is equal to pi r square h. So these are the formulas of volume for different shapes. So we need to know them, and with those we can calculate the volume, and then we calculate the density using the formula. Then density of an irregularly shaped solid. So we measure the mass of the solid using a balance. Then we measure the volume. To measure the volume, we fill a graduated cylinder with water to a known initial level. Let's say we filled the water till 10 cm cube. And then we submerge the solid in the water, and we have to ensure that it is fully submerged. And after that, you will notice that there is a rise in the level of the water. So let's say after we submerge the solid, the water level reached 40 cm cube. Now to so we noted the new water level, that is 40, and the initial was 10. And to get the volume of the object, 40 cm cube or 40 m cube depending on what cylinder you are using, but cm cube we can take. So then to calculate the volume of the object, we'll just do final, that is 40 minus 10. So we'll get 30 cm cube. That's the volume of the object. And then we can calculate the density using the mass over here and the volume we have got here. So we'll get the density. Now, where we can use this density is on the floating and sinking. So we have the key principle over here is that an object will float if its density is less than the density of the fluid it is placed in. And if the density of the object is greater than the liquid's density, the object will sink. For example, we have a wooden block. It floats in water because its density is less than water. Density of water is 1000 kilogram per meter cube, but the wooden block's density is lower than that. That's why it floats. If the density of an object is greater than that, then the fluid it is placed in, it will sink. Now, floating of liquids on one another. So, when two immiscible liquids, immiscible, the word immiscible means that they do not mix. They do not mix. So, when such liquids are placed together, the liquid with the lower density will float on top of the denser liquid. So, for example, we can have oil and mercury. So oil, the density of oil is 920 around kg per meter cube, and the density of water, as I told, it's 1000 kg per meter cube. So the density of oil is lower than that of water, and hence it floats on water. Density of mercury is 13,500 kg per meter cube. So it sinks below water because mercury is more denser than water, it will sink and water will float. But in oil, oil has a lower density than water, so oil will float and water will be lower. Now, to determine which liquid floats, we have to measure the densities of the liquids using the formula. We compare the densities, and the liquid with lower density will float. Okay, now the applications of density, we use density in daily life in floating and sinking, as I told. So the ships float because their average density, including the hollow parts and everything, is less than that of water. If the density of ship was greater than that of water, it would sink immediately. But we have to take care that the ship's density is lower than that of water. Oil spills. Now, oil floats on water due to its lower density, making it easier to clean up when there are oil spills. And material selection. So, engineers select materials based on density for specific uses, like lightweight materials for aircrafts. So, this is the end of the topic, and I'll see you guys in the next video.